Ayun. All right. Good morning, everyone. So this will be our discussion for today. No, so makita nato sa screen. We have different pictures. No, but before that, let's have a brief review of our discussion last week. So last week, we discussed the introduction of thermochemistry as well as the heat flow. No, and you all know that there are two terms that we will be using in the entire thermochemistry lectures. No, these are energy and of course heat, and we described them both last week, and we know the difference of those. And now, aside from that, we also discussed how to identify of a surrounding and a system. No, so on that part, we will be expanding our knowledge about systems. So we have here different kinds, or I mean not kinds, but different types of a system. We have an open system, an isolated system, and closed system. So to start with, I would like to know if you have any idea about what is an open, isolated, and closed system. So to know, I want you to identify among the three, A, B, C. No? A as thermos na kanang tumbler, B as the bottle, no, na say for example na siya sulod, so that would be the system. C is kaning cup of coffee, no, cup of hot coffee. Now, I want you to identify and kindly just chat on our chat box whether asa siya dinhi, okay, sa pag-identify nato. Now, based on the images that you can see here on the screen, which do you think is an isolated system? Is it A, B, or C? Let me know in the chat box. Okay, karamihan ng sagot is letter A, no? Meron lang isa na nag-B, no? But anyway, so according to your assumptions in this question is that the isolated system is letter A, right? How about the closed system? Is it B, A, B, or C? Uy, daghan nag-answer B. So, ibig sabihin, ang letter C would be the open system. So, how did we know, or how did you know that those are the systems that depicts or shows in our images here on the screen? How did you define, or how did you determine? So, anyway, I'll just answer that one. So, for isolated system, you are correct that it is actually letter A. So, how do we define an isolated system? An isolated system is where matter and energy cannot be transferred between the system and the surroundings. So, ibig sabihin, they are most likely to be much isolated with one another. Maybe that's why ang thermos is a good example for that, no? Because since kwan man siya, since if you put hot water or cold water there, it really takes a very long time, no, if for it to cool down. Samot na ko katong mga mahalon kay na thermos inyong gamitan. It's because the matter and energy cannot be transferred within and between the system and the surroundings. That's why it's an isolated system. If a system is like this, no, nasa sa isa ka-isolated, so isolated na materials, it can be determined as an isolated system. Kapag sinabi naman natin closed system, just like this one, say na siya water dire sa bottle, no, the closed system, they can only transfer energy between the system and the surroundings. It means that the matter or the amount of matter will not change, no, even if the energy can be transferred. So for isolated, there is no transfer of energy or matter. Pag sinabi natin closed system can only transfer energy but not the matter. So a very good example of that is a closed bottle containing, say for example, a coffee, no? So eventually later on though, for a short period of time, it will cool down, no? Kung unsay naa dito, kung init siya, say for example, hot water or hot coffee, eventually it will cool down, no, at room temperature when, of course, what do you call this one? If they are put in a room temperature na room, no? So, but however, since the energy is being transferred, the mass remains the same. Kapag sinabi naman nating open system, open system, so nakikita natin, wala talaga siyang wala siyang barrier, kumbaga, no? So, if we see the system as such, ibig sabihin, the transfer of the matter and the transfer of energy, it occurs between the system and the surroundings. The system interacts with the surroundings, as you can see. So, a very good example is that, easily, kapag open ang system natin, the coffee here will cool down much easier compared to the closed and isolated system. So these are the type of system that we also need to understand and to know. So going back to the heat flow that we discussed last time, we discussed the heat flow as equals to mass times specific heat times delta T. That is if it is a pure substance. If it's not a pure substance, we can just use the Q. Q equals to C delta T. No, so that's for the heat flow. So the next thing that we need to discuss is about work. Okay, about work siya. Work, charot. Okay, maulot na kay Dance, kay Singarus Bianis si Dance. No, kay nasa sa choir. Charat. Okay. Work has a symbol of a small letter W, no? Small letter W. As you all know, kung ma-remember niyo sa physics, work is equals to force times distance or displacement, no? And this will be the formula that is most likely to be the basic formula for work. Work is either a positive here or a negative. Same siya last time, di ba? Natay Q positive, naputay Q negative. Then, pag magstorya putag about work, the work can also be a positive or a negative. So, kanis naman ta makaingon that work is a positive or that work is a negative. Unsa tawagan ni, if the system is being compressed, it means that the work is a positive. How would we know that there is compression instead of expansion? If compression kasi siya, the work is done on the system. Ibig sabihin, on the system siya, o sa tawagan ni, the surroundings, ibig sabihin, the surroundings do the work on the system. So, mura po siya tong Q positive, pero ang kalainan lang na term na ginagamit would be the term work instead of the heat flow or energy. No? So, another one is kung negative naman siya, it means it is expansion. So, how would we know that it will be expansion? It will be expansion if the system does the work on the surroundings. So, ibig sabihin, pagawas ang work from the surroundings, no? Or I mean, from the system to the surroundings. So, paano siya? So, ang work would be out of the system. So, if that will be the case, work should be a negative. So, again, work is a positive if there is compression, and you would know it is compression if the surroundings do the work on the system. If the work is a negative, it means that there is an expansion. So, ibig sabihin, it will be out of the system because the system does the work on the surroundings. Now, speaking of this one, no, to determine the magnitude of work, we will be deriving an expression for work where a change in volume is used since there is expansion and compression. Again, since compression and expansion is being involved here in work, we will be changing, no, we will be changing from this formula, mag-derive tag another formula wherein when we say compression and expansion, a volume should be included para malaman natin if there is really expansion or compression based on the volume. So, the volume can be calculated as delta V, the change in volume equals to the final volume minus the initial volume. And from that one, from the definition of work, work is equals to, di ba? Work is equals to force times distance, right? So from here, later, hinahinayon na to ni siya. And pressure is equals to force over area. And force applied has a negative magnitude, making the expression becomes work equals to negative P. Since pressure is force over area, so we will be using pressure. Pressure that is applied would be negative. So take note of this one, nga negative yun ang pressure dapat permanente. Okay? The pressure that is applied times the area coming from this one, and the distance or the change in distance that will be, or the change in the distance that will be used for this formula. But instead of, no, after you multiply area from the distance, you will have the delta V. So, rewriting the formula, your final formula would be, since again, kailangan nato mapakita ang expansion and compression, we will be using the delta V. So, the work now has a formula of work equals to the negative pressure that is applied times the delta V, or the change in volume. Remember, by the way, that the work has a unit of joules. So, dapat naka-joules tanan. However, though, it's either joules or kilojoules. Yun ang ato ang ginagamit. Samot na kung dako na kayang value sa joules. No? Inya, kailangan na to express siya into a smaller number so we can convert a joule to kilojoule. And by the way, kani siya, please take note of this one, ito yung conversion factor. It's because kadalasan, ang unit na inyong makuha would be liter atmosphere. So, to convert liter atmosphere to joule, kasi nga kailangan natin i-convert ang ating mga sagot into joules or kilojoules, then we have to convert liter atmosphere, and per 1 liter atmosphere, it's equals to 101.3 joules. So take note of this for your conversion factor. Now, please take note that the negative work occurs when a system does work on the system. Okay? Again, the negative work will only be possible if there is an expansion and when the system does work on the surroundings. Now, basically, kay volume man ato ang focus din ni karon, the work will be negative if the volume or the delta change in the volume is more than 0. The work will be a positive if the delta V will be less than 0. So, mo ni siya ang mga assumptions that you need to take note as well. So, yan lang. Okay, so, do you have any question? If you have any question, you can send your questions in our group chat. Chat box here. And I'll just read the question so we can answer it together. Any questions or clarification so far? Sure? Okay. Since there is none, so we will be continuing with our word problem. Now, this will be the first problem that we will be answering, with regards to work. So let me read the problem. How much work is needed in a system to expand from 25 to 50 liters against a pressure of 5 atmosphere? Is work done by the system or on the system? Now, I want you to try this one, and I will give you 5 minutes to do this. Try and answer this problem. Alright? Let's go. Alright. To calculate or to answer the problem, now let me read it again. How much work is needed in the system to expand from 25 to 50 liters against a pressure of 5 atmosphere? Is work done by the system or on the system? So, to compute this one, we'll just use the formula of work, wherein work is equals to the negative pressure that is being applied times the delta V, or the change in volume. So, as you can see here, nag-substitute lang tag value. We have 5 atmosphere, so negative siya automatic. We have 50 liters minus 25 liters. So that would be 25 liters. So 25 liters times negative 5, that is equals to negative 125 liter atmosphere. So nakita na to ang unit na liter and atmosphere. So since naka-liter atmosphere siya, we have to convert it. No, motong conversion factor na ako ang gihatag sa inyo ganina. That 1 liter atmosphere is equals to 101.3 joules. So, after convert, kanay diri nga part, this is the conversion part. Okay? Mag-convert mo din he. Okay? I-convert ninyo ang negative 125 liter atmosphere to joules para maging joules ang inyong answer. So, that would be negative 125 times 101.3. So, cancel out na ang units na liter atmosphere. So, you will have 12,662.5. No? Negative 12,662.5 joules. However, since this value is very high and we cannot transform it into a scientific notation, so the best thing to do here is to convert it into kilojoules, a smaller value for it, no? Para magkaroon tag smaller value niya. So, conversion, after converting, you will have negative 12.7 kilojoules. So, diligyapon siya ang atong maingon na final answer, but this would, it did not suffice, no, the correct number of significant figures. However, we cannot do anything anymore about it. If this will be the case, then kung unsa tong pinakagamay niya na value, mo lang na siya tong pwede dawaton. Okay? So that would be negative 12.7 kilojoules. And as you can see, work is equals to a negative. So dito na to maingon, tamang answer nila Dance ganina, nila Diana, no, nila Claire, that since the work here is a negative, therefore the system does the work on the surroundings. So that would be the answer for this question. Okay? Do you have any clarifications or concerns? You can type it here on our chat box, and we'll read the problem out loud. Okay? Or the question out loud. Okay, so we're done already with work, no? So now we'll proceed to the next part, which is the internal energy and enthalpy. So internal energy has a symbol of capital E, no? Capital E siya. It is the sum of the kinetic energy and the potential energy. That's why makita niyo there is KE plus PE. It means that when you sum the kinetic energy and the potential energy, it will result to the internal energy. So since it is the total energy found on the system being studied, the internal energy is not quantifiable. Ibig sabihin, you really cannot quantify it unless it will be a change in the internal energy. The change in the energy of the system can be determined by getting the difference between the final and the initial energy value. So that's why delta E, or the change in the internal energy, is equals to the energy or the final energy minus the initial energy. And the delta E, or the energy, na naput ni siya si signs din na naput tayo positive, na naput tayo negative, no? So, kanina, change tag color. So, how would we say that the delta E is a positive o sa iyahang mga assumptions dito apil? Kung delta E siya, o yan negative siya, what will be the assumption of that? Now, kapag positive siya, ibig sabihin the energy or the positive delta E means that the energy is gained from the surroundings. So, halos pareho lang po siya sa Q. Remember mo sa Q? Di ba, ang Q or the heat flow is becomes a positive if it will absorb heat from the surroundings, di ba? But here, instead of absorb, it will gain. No, ang term lang niya na nagamit will be gain instead of absorbing. Okay? So for a positive delta E, or the change in energy or internal energy, if it is a positive, it means that it gained energy from the system. A negative delta E naman, or the change in internal energy, means that the energy was lost to the system. Ibig sabihin, nag-release naman siya o iyahang internal energy to the surroundings. So, from system to the surroundings. So, from this, we can say that when the heat is absorbed by the system and the surroundings are doing work on the system, the change in the internal energy will be positive. And on the other hand, in a system that releases heat and doing work, the delta E becomes a negative. So, there are two assumptions that we need to also remember when we talk about the law of energy conservation, which is the first law of thermodynamics that is very evident in the delta energy. Work, heat, or both may cause a change in the internal energy. So, just ay sa magtanaw aning problem. Diri pa to sa taas. Napatad din ha. So, delta E is also equals to Q plus W, wherein Q is the heat flow and W is work. No, if you can still remember. If the system is held constant, the work will be zero. Okay? If the work is zero, it means that the amount or the system has a constant volume and will be held constant. No, pag ang work niya would be zero. If the internal energy is equals to the work, if the internal energy is equals to work, it means that there is no heat being transferred, or there is no heat transfer that is allowed on the system. So this is according to the first law of thermodynamics, which is the law of conservation of energy. And now we will proceed to the next problem. So makita naman niyo daan, no? So the problem states that a system receives 450 kilojoule of heat from its surroundings, and the surrounding do 50.0 kilojoules of work on the system. What is the change in the internal energy? So, since ang atong ginastoryahan is heat and work siya, so we will be using this formula, which is the delta E equals to Q plus W, wherein Q, if you can still remember, is the heat flow, W is work. So, i-add ni mo na siya, that will be the change in the internal energy. So, since there is a change in internal energy because the heat flow is at 450 kilojoules, so 450 kilojoules, plus the work that is done by the surroundings on the system, which is 50.0 kilojoules. And this would be the total, which is 500 kilojoules. Now, it means that sa 500 kilojoules, since it is a positive one, it means that the energy is absorbed or gained from the surroundings. That's why a delta E becomes a positive. Now, question. Kailan natin masasabi na ang delta E will become a negative? If, yes, anyone, kindly type on our chat box. Kailan natin masasabi that there would be a negative delta E? Okay, very good. If there is a loss of energy to the surroundings, it means the delta E will be negative. So, either of the two, no? Pwede po, kaning duha mismo ang mali, no? Or kaning something na problem. So, if the Q becomes a negative, and any questions or clarifications on this part? Ayaw kaulap. Na nag-chat po sa ko sa Facebook. Check sa nako. Okay, if you do not have any question again, we're done already with internal energy. So, we'll proceed to enthalpy or the capital H. So, makita nato din na siya capital H.
Okay.
So, okay, enthalpy or capital H is the equal to the amount of heat flow in a system with constant pressure Q, wherein Q, that is applied pressure, no? Because the delta E is equals to Q plus W, and W is equals to negative PV delta V. So what I'm talking about here is that the heat flow, okay, what I'm talking here is that the heat flow, kaning Q, is also equivalent to H. So, mo na, makita na to, Q equals to H. Wherein, kapag i-rewrite na to ang formula, it becomes AE, no, or add AE, delta E equals to Q plus W. Kasi again, the sum of the heat and the sum of the heat flow and the work is equals to the delta E, di ba? Or the internal energy. And work is equals to negative P delta V, wherein Q is equals to delta H, no? Wherein Q is also equals to the delta H, or the change in enthalpy. It will be then equals to delta E plus na P delta V. Okay? So, mo na siya ang iyahang maging formula. Na question. Na ba may gusto ipangutana, ma'am, giun sa man pagkuha? Gusto niyo mabalaan giun sa pagkuha? Pangutana mo. Mamugos, no? Mamugos ba? Pangutana mo. Lagot kasi kuan ay. Kanila. Anna siya, no? It's very good that you asked that question. How was this one being kaning, di unsa siya pag-derive sa formula. So, this is how it was derived. Okay? Human na putaan na. So, dire. Di ba, delta E, mura na siya A din hemo, no? Say, malipat ko, A na ko gid siya. So, let me rewrite this one. Di ba, this one is delta E, right? Delta E, or the internal change. Internal change is equals to heat flow plus W. Wherein, di ba, ningon ko ganina that the heat flow is equals to the change of enthalpy or enthalpy, no? So, i-write lang nato na siya. Ang Q, tanggalon nato, buhaton nato siyang delta H. Alright? So, ibig sabihin, pag re-write nimo sa internal energy formula will become internal energy equals to the delta H, or enthalpy, plus work. However, since work, okay, ato sa ding sa ding sa tawag ni ang sige ni mathematical term ani transpose, no? So, we will be transposing kay para ma-derive na to ang formula. So, the positive W here becomes a negative. So, it becomes delta E minus work equals to delta H, which is the enthalpy again. So, since minus naman siya, minus times minus, it becomes a positive. That is why, mahimong positive ang P din karon. So, it will be delta E plus P delta V equals to delta H or Q, which is, mo na niyang formula na ato ang gamiton for this problems, no? Problems concerning enthalpy. So, enthalpy will be equals to the delta E, or internal change, plus P, pressure applied, times the delta V, or the change in volume. Okay? So, mo na ni siya ato ang maging and problems now. Now remember the delta H, or the enthalpy, becomes a positive if it is an exothermic reaction. So endothermic reaction. The delta H, it means that it has a more than value, or more ang ihang value kaysa sa zero. So delta H has a greater value than 0. So, it means that it will be a positive. If the change in the enthalpy, or the enthalpy value, is less than 0, it means that the delta H will become a negative. Same lang good gihapon siya sa Q positive o Q negative. Lahi lang yun ang mga terms na ginagamit. Alright? So, the next topic is actually mo to itong una na discuss, which is the calorimetry. So, the answer na, na nato ni siya, na-discuss na nato katong about sa Q equals to MC delta T. So, that was our discussion previously, no, the calorimeter. So, we'll proceed to heat of reaction. So, hapit na ta mahuman. Okay? sa heat of reaction, okay, we'll be talking about the heat of reaction. So, the heat of reaction is actually the enthalpy change for the chemical equation as it is indicated. Um, So now we'll proceed to our next topic, which is the heat of reaction. So again, heat of reaction is the enthalpy change for the chemical equation as it is indicated. No? So as you can see, the delta H, actually, mas pareha lang yung gyapon siya. Enthalpy yung gyapon na itong ginistoryahan. However, specific yun ang heat reaction din kasi mo na yun siya ang enthalpy change niya. So, you see, there will be chemical equations that will be involved in this topic. So, I'm just hoping that you can still remember how to balance an equation and how to apply stoichiometry in word problems such as this one. Kasi pag dili na ninyo mahinumduman ang stoichiometry, akong maingon ng yun kay afatay. Oo. Kasi, diri na pod mo balik ta. Actually, this is just, unsa bitaw naman. Unsa bitaw, stoichiometry. Stoichiometry, apel tong mole concept, no? Sa chemical equation, kailangan makainumdum mo ani. First ha, how to balance the equation. Remember, katong kailangan magbutang ka og big number or coefficient tapad sa chemical equation or sa chemical compound para mabalance siya. Kasi to balance an equation, you have to make sure that the number of atoms of each element on the product and on the reactant side should be equal or the same. Di ba mo na yung goal? Ang next ninyo is dapat may numduman gid ninyo ang stoichiometry. Okay? Katong mga coefficients will be used as your number of moles as well. Okay? Na chemical equation. So, hinahinay sa ta. Actually, dili ko sure kung napa ko yung video anto, pero try na ako pag-check, no? Sabay na lang na ako send sa inyo kung naa siya. Okay? So, usually, no, heat of reaction is written as delta H. Also the same with the change of enthalpy. Since, again, heat of reaction is the change in the enthalpy. So, knowing or seeing the equation here, we have calcium oxide plus water, and then it results or the product is calcium hydroxide, right? In this reaction and in other exothermic reactions such as this one, the chemical potential energy of the reactant is higher than the chemical potential energy of the product. Why? Nga naman, makita nato din that the energy is a negative. It means that it releases the energy. So, as the chemical reaction took place, pag-react nila with one another, more of the energy is being released to the surroundings instead of absorbing. That is why it has a negative sign here. So, ibig sabihin, there is a 65.2 kilojoules of heat that was released from the system to the surroundings. So, diri na siya, murag kumbaga byproduct ni siya. So, if the reaction also absorbs heat from the enthalpy change, so we will be considering this equation here on the lower part. So, dili pa man ni siya, dili ninyo makita ang whole, no? Kadali. Pag-amune na to. Okay. Taas gid siya na equation manggod. So, natay sodium hydrocarbonate plus 85 kilojoules. Ibig sabihin, nag-absorb siya og 85 kilojoules in order for the equation to take place. So, if you can remember, kung pag makita ninyo ni siya, di ba, this one will be AB yields to A plus B. No, kay kani man siya sodium carbonate plus water man siya plus carbon dioxide. Dili na ko ma-move ang carbon dioxide. So kung mainumduman ninyo, kani siya na general equation katong AB that yields to A plus B, di ba decomposition siya? Ibig sabihin, ibuwag ang sodium hydrocarbonate, no? So, since buwagon siya, kailangan niya mag-absorb og 85 kilojoules para mo proceed ang chemical equation. So, kani siya, it means positive. Ang delta H din is a positive 85 kilojoules kasi it absorbs the energy in order to decompose this reactant to this product. Sodium carbonate, we have sodium carbonate, we have water, and then we have carbon dioxide. So, kung makita, kung inyong mapansin, ang positive ug negative dire, pareha ra gyud gyapon siya dito sa giunsa siya pag-define. It's just that kapag sinabi nating negative ang iyahang heat of reaction, it means that it releases the energy. Kapag positive ang delta H, it means that it absorbs the energy. There will be problems that involves enthalpy changes and will be solved similarly with how you solve stoichiometry problems. So, mo na siya ang problema ron, no? Sa stoichiometry problems. The amount of the heat absorbed or released depends on the number of moles of the reactants that is involved. So, for example, no, the formation of moles of carbon hydroxide, katong sa kanin siya, no, the formation of carbon hydroxide, in order for this calcium hydroxide, in order for this calcium hydroxide to be formed, you will need, or the reaction, no, calcium oxide plus water needs to release 65.2 kilojoules in order to make such product. Okay? Mo na siyang iyahang pasabot. So, let's try and let's apply the sa tawag gani, the statements or the assumptions for the heat of reaction in a problem. Okay? So, dali lang ni siya. Let me... Okay. Looking at this problem, no? So, we have a problem here. Calculate the amount of heat in kilojoules required to decompose 4 moles of iron 203. Given that the delta H, if unsa tawag gani, in every 1 mole of iron 3 oxide, there is an enthalpy of 26.3 kilojoules. And for delta H, or the enthalpy, or the change in enthalpy for every 4 moles of iron 3 oxide, mo ni dapat inyong makompute pila ang iyang total amount of heat nga kailangan in order na matanggal or mabuwag daw nimo ang iron 3 oxide. So, in a most simple way, para makuha lang siya, is actually to convert. Okay? Ang problemahon man ninyo dinhi kung instead of moles ang gihatag, mass. Diba? So, sa inyong gamiton, kung mass ang ihatag dinhi, i-convert niyo siya to moles. So, unsaon man ninyo para ma-convert sa moles? Get the molar mass or molar weight. Ha? Timan-an gyud na ninyo kay mo ninyo mga gamiton para sa conversion. So, in every 4 mole of iron 3 oxide, you will be needing 26.3 kilojoules in every 1 mole of this. So, ang buhaton lang ninyo, convert. So, multiply 4 times 26.3, you will have 105.2 kilojoules. Okay? Question so far? Clarifications? Yes, that's. So, to sum it up, so we discussed the first few lessons under thermochemistry. So, please watch out for my next video about Hess law and standard enthalpies of formation, which is the last topic to be discussed under thermochemistry. Okay? Bye-bye!